The concept of isolation between network slices is a central point for 5G in terms of traffic, security, and performance. In this video, we demonstrate performance isolation, a network slicing capability providing per-slice traffic, bandwidth, and delay isolation guarantees in an SDN-based network. It is worth noting that such isolation is independent of congestion and performance levels of other slice instances sharing the same infrastructure. Starting from traffic isolation among slices, by utilizing the VPLS, we can monitor and control closely the traffic using standard metering. To go beyond the limited information provided by metering and to also meet advanced delay guarantees, we introduced the use of virtual queues in the P4 pipeline. Such virtual queue mechanism aims to model the sojourn time of the queue, as if the packets arrive at the real queue with per-slice defined capacity. Via using virtual queues to perform policing, we can meet the delay requirements of each slice. To demonstrate that our slicing capability is portable to multiple SDN technologies, we showcase the performance isolation under a mixed data path composed of two SDN protocols, OpenFlow and P4. OpenFlow protocol is capable of performing basic traffic metering, and P4 protocol can perform both traffic metering and the aforementioned virtual queuing, providing bandwidth and advanced delay guarantees. Furthermore, we deploy ONOS to control and coordinate the SDN protocols. ONOS is a carrier-grade SDN controller, being capable of managing OpenFlow and P4 protocols. Nevertheless, ONOS nowadays only provides traffic isolation across slices by using VPLS native application, without the capability of bandwidth and delay guarantees. Therefore, 5 Growth has introduced QoS slicing as an application managing both meters and virtual queues across slices and exposing a unified interface towards the upper control layers. To expose performance-isolated slicing to the verticals, we developed 2 plugins for 5 Growth Resource Layer: Virtual Infrastructure Manager plugin and Wide Area Infrastructure Manager plugin. These 2 plugins will enable an end-to-end deployment for performance-isolated slices across different points of presence in the transport network. Regarding the evaluation of network slice performances, 4 key performance indicators are introduced. End-to-end latency by measuring the round-trip time between 2 endpoints in a slice. Throughput of each slice. Virtual delay measured from virtual queues. And real delay, measured as the experienced delay of the physical queue. In the first step of demo, we show the system behavior with no performance isolation in the slices, and a traffic flow saturating the maximum capacity. As we do not enable any bandwidth or delay guarantees, the end-to-end latency will increase up to more than 2 seconds. This large latency is caused by the full utilization of link capacities and the buffers filling up. Now, let's activate the performance isolation in one slice. It is configured to guarantee 12 megabits per second and 10 milliseconds delay. As the throughput guarantee is below the maximum capacity, 0 real delay is shown and the buffers are not filling up. The virtual delay experienced at the virtual queue limits the bandwidth to 12 megabits per second. Now let's increase the rate limit to 120 megabits per second. As the guaranteed throughput is above the 70 megabits per second maximum capacity, the results show that the real delay can be bounded to 10 milliseconds latency, together with no virtual delay, because there is congestion at the real link and the virtual queue rate limit is not reached. Now, let's add the second slice. Both slices are rate limited to 48 megabits per second, and slice B is configured with only 5 millisecond delay guarantee. As slice A has a higher delay guarantee than slice B, it will be limited by the virtual queue, while slice B will be limited by the maximum capacity and the real queue. This means that the slice with the most stringent delay bound determines who will suffer from lower throughput. Such phenomenon can be further revised or even reversed via using multiple real queues with weighted schedulers or AQM mechanisms. The technical details on supporting performance isolation for network slicing and the details of this demonstration can be found in the links that you see on the screen. Thanks for watching.